I'm Patty Simpson with Simpson Math. In this video, we're going to graph polynomials. In a previous video, we looked at the end behavior and were able to give a sketch of those polynomials. And we're just going to add a few more details in this video. So in the previous videos, we looked at the end behavior and what was happening on the ends of our polynomials. We're going to add to that in this video the Y-intercepts. Now, let's think about those Y-intercepts. You know, we have a Y-axis and an X-axis. And the Y-intercept is just where the graph intercepts that Y-axis. In other words, it's just a point somewhere on this Y-axis. And if you think about the points on this Y-axis, so like maybe this point right here, if I label that, the point there is 0, 2. This point down here is at 0, negative 3. Notice that wherever I put a point on this y-axis, that my x value is equal to 0. So when we find the y-intercept, every single time we're going to substitute in 0 for x. That's how we're going to find that y-intercept. We're just going to substitute in 0 for x and find our y value. Then we're going to find our x-intercepts. And just like our y-intercept is on that y-axis, our x-intercept is on our x-axis. So along that x-axis, there are points on the x-axis, such as this point right here, which I would put at 3, 0 is the name of that point. Or another point on this axis is here at negative 2, 0. Notice that if I put points along that x-intercept, that every time my y value is 0. So to find my x-intercepts, every time my y value equals 0. So I'm going to substitute in 0 for y to find those x-intercepts. Solve for x and I'll find the x-intercepts. Then we're going to look at something called multiplicity. And multiplicity is just the number of times a graph, a root shows up in the linear factors of that graph. So this is the multiplicity is the number of times a root occurs. And we'll talk more about that here in a little bit as we do the graph. It's going to tell us at that point what happens. So it's going to tell us if it crosses the graph or if it turns at that particular point. And then the last thing we're going to do is graph it. So let's go through and let's just look at those pieces. I have here a polynomial for us to do. The first thing we're going to do is look at the leading coefficient. Remember that leading coefficient, that's what that LC is. When the leading coefficient is positive, then on the right it's going to rise. And when the leading coefficient is negative, then on the right it's going to fall. And the leading coefficient is just the coefficient on the term with the highest exponent. Or on this fourth degree term here, this is a fourth degree polynomial, and so my leading coefficient there is negative 5. So notice that in this case, my leading coefficient is a negative number. Because it is negative, I know that it is going to fall on the right. Then I'm going to look at the degree of the polynomial. That stands for degree of the polynomial. And if I look at the degree of my polynomial, this is a fourth degree polynomial. So the degree of the polynomial is 4. When that degree is even, we have same end behavior. Let's see, it's falling on the right. So when the degree is even, we have same end behavior. When the degree is odd, we have opposite end behavior. In this case, my 4 is even, so therefore we're going to have same end behavior. That means since it falls on the right, it's also going to fall on the left. In my class, we're sure to write down each one of those important little pieces of information to let our reader know how it is we know that it is falling on the right and falling on the left. The fact that it is even tells us that it's going to be the same, and therefore it's going to fall on the left. Then we can tell how many terms and how many roots we expect, also based upon that degree of the polynomial. So here the degree of my polynomial is 4. Well, 4 minus 1 is equal to 3, so there will be 3 terms. Then also my degree of my polynomial is 4, and since it's 4, we're going to have 4 roots. As I go through, I'm now going to, so that's my end behavior. Based upon that, last time we gave a rough sketch. I can do that here as well. I know it's going to fall on the right, it's going to fall on the left. There's going to be 3 turns, so 1 turn, 2 turns, 3 turns, 1, 2, 3. My graph is going to look something like this. Then the next thing I'm going to do is find the Y-intercept. To find the Y-intercept, I'm just going to substitute 0 in for x. Every time to find the Y-intercept, that's how we find it. So I'm just going to substitute 0 in for my x value. And here I have f of, I'm putting in 0 for my x value. So I have negative 5, 0 to the 4th power. Plus 7 times 0 to the 3rd power minus 2 times 0 squared. And if I do the math there, that's just equal to 0. So I know that my Y-intercept, remember they were points. I drew points on that Y-axis. So when I get ready to tell my reader what the Y-intercept is, I need to make sure to put it in a point as a coordinate. So my x value is 0 and my y value is 0. This particular one has a point at 0, 0. I could go ahead and put that on here. That's going to be my Y-intercept on that y-axis. Then to find my x-intercepts, I'm going to plug in or substitute in 0 for y. So into my function where my y is, remember that f of x is the same thing as y. I could replace that with y. So I'm going to put in 0 for that y to help me find those x-intercepts. So substitute in 0 for y. So we have negative 5 x to the 4th plus 7x cubed minus 2x squared. Then what I'm going to do is factor. I'm going to go ahead and factor it. You can go up to the side and see if you can factor it the same as me. I'm going to skip right down to the punchline, right down to the factored form, just so that we can find those roots a little faster. But go through your AC method to see. First, pull out your greatest common factor. A leading negative always comes out. Use your AC method to find those factors. Then once I have those factors, let's go ahead and put this in linear form. By the way, I could divide both sides by -1 here to help me solve for this x. If I divide this side by -1, I just end up with a positive there. And if I divide this side by -1, I just end up with 0. Now, to write these in linear factors, I want to write them with a 1 there. Normally when we write it in factored form, we would leave it like this. But when I'm finding the roots, I want to see it in linear factors. So therefore, I'm going to write it, each one of these is a linear x. In other words, where my degree is just 1. And I can see that I have 4 roots there, or 4 linear factors, 1, 2, 3, 4, which is what we said we were going to have back here. As I solve for each one of those to find out my x values, remember that my x-intercepts again are points. So I have a 0, 0. Remember I said each one of these equal to 0 and solve. 0, 0 shows up again because this x is going to equal 0, that x is going to equal 0. Here my x is going to be 2/5. So 2 divided by that 5, and then my y value is 0. And if I solve that one after I set it equal to 0, I have 1, 0. So I have 4 x-intercepts there at 0, 0, 0, 0, 2/5, 0, and 1, 0. Notice I have 4, just like we said we were going to have over here. The multiplicity then is the number of times that x-intercept shows up. How many times do we see that linear factor occur? So how many times does it occur? Well, here we have 2 of those. So this 0, 0, that x-intercept has a multiplicity of 2. Has a multiplicity of 2 because it shows up 2 different times. Whereas 2/5, 0, that one only shows up 1 time, and 1, 0 has a multiplicity of 1 as well because it just shows up once. Now, what the multiplicity does is it tells us what's going to happen at the graph at that point. When I have an even multiplicity, when my multiplicity is even, the graph is going to turn at that point, or you can say it bounces at that point. When the multiplicity is odd, it's going to cross at that point. So anytime I have a multiplicity of 2 or 4 or 6 or 8, I know at that particular point the graph is going to turn around. When I have a multiplicity of 1 or 3 or 5, if the root shows up over, the x-intercept shows up that many times, an odd number of times, then it's going to cross the graph at that point. And now let's graph it. So I'll show you what I mean. Here, I'm going to put those points. We have 0, 0 there. Now I'm going to put on my x-intercepts. 0, 0. Oh, we already have that one there. 2/5, so that's not over very far. 0. And then 1, 0. Man, these roots are pretty close. Maybe I should count by fifths. Let's do that. Let's count by fifths. And then that way, if I count by fifths, 1/5, 2/5, 3/5, 4/5, and then that's 1, we'll be able to see just a little better what's happening with this graph. So 2/5, 0, and at 1, 0. So now, what's happening? Well, I know on the right, it's going to fall. So I'm going to start with my end behavior. Once I get my x-intercepts and my y-intercepts up there, then I'm going to use my end behavior to help me graph it. I know on the right, it's going to fall from that point. I know on the left, it's also going to fall from that point. So on my left over here, it's also going to fall from that point. Then, this multiplicity tells me what's happening in the middle. So at this x-intercept, 0, 0, it was even there. It showed up twice, so it's going to turn at that point. In other words, when it hits this 0, 0, it's going to turn back around. So I'm going to hit this point and come back down. Now, it's a mystery right now how far down it's going to go. We could do things like plug in 1/5. We could substitute 1/5 in for x to find our y value. In calculus, we're going to learn where those turnaround points are. Here in college algebra, we're just going to kind of give a sketch of the graph. It's okay not to get it just perfect. So here, somewhere down here, it's going to turn back around. We know it's going to turn back around because it's got to come back to this point. So somewhere along here, it turns back around. When it does, it comes and hits that point. Because this point only showed up once, its multiplicity was odd, it's going to cross at that point. So here it crosses. Again, I don't know how far up it goes. Maybe it goes way up here. Maybe it just barely goes across like that. I could find out a little more specifically by substituting in 3/5 and 4/5 for x values. But we're just going to kind of give a sketch. So we just know that it does turn around somewhere because it's got to come down to this point. And from this, I can tell that it's going to cross through because it's got to fall down there. But in addition to that, my multiplicity, because this is 1, I know that it's going to cross at that point because that x-intercept only showed up 1 time. It had an odd multiplicity, so it crosses. So here's really what we've added this time. We know that to find the y-intercept, we're always going to substitute in 0 for x. To find the x-intercepts, we're always going to substitute in 0 for y. And then when the x-intercept shows up an even number of times, we know it's going to turn around at that point. Whereas if it turns up an odd number of times, it's going to cross through at that point. So there we have graphed our polynomial. Don't forget to label your points so your reader knows exactly what it is that you've found. Other than that, we have the graph here of a polynomial. This is a 4th degree polynomial, and there are our points labeled. In the next video, we'll do another example of graphing a polynomial. Math Made Simple at Simpson Math. Thanks for watching.